Alright, the next question is about the Powder Snow Ski Resort. I really like this question because it's a very non-traditional application of Little Slow. In this question, what it says is one of their triple chair unloads 1296 skiers per hour to the top of the slope. So this is the capacity. The capacity is expressed in terms of 1296 skiers per hour. This is for powder snow. The capacity is expressed in terms of 1296 skiers per hour. Then the question says, well, the ride from the top to the bottom to the top is 5 minutes. So this we can think of it as the flow time. Flow time is 5 minutes. Now, this capacity really is flow rate here, and that you should know from our previous process analysis part is really process capacity becomes flow rate in the absence of demand. So they're similar units and they're very closely related. Now the question asks you how many skiers are riding on the lift at any given time. So this is very it's easy to see that it's the inventory in the sense how many people. So if this is the hill, and if this is the chairs, what the question is really asking is, if you take a snapshot of times, how many people are there in these chairs? It takes 5 minutes to go from here to here. The ride is 5 minutes. If you sit at the top and count the number of people coming from this from the lift, you will see that the rate is 1296 customers per hour. So very interesting applications for Little Slow. So we want to find the inventory. We have R and T. Our R is 1296 customers per hour. Our T is 5 minutes. Well, the problem here is this is in terms of hour, this is in terms of minute. It's probably easier to convert that in terms of hours. So let's leave this 1296 and let's convert that into hours. 5 divided by 60. Now we have converted that into hours. And this comes out to be 180 skiers. Now you might wonder, what does that triple chair really mean? The triple chair really means there are 3 people in each chair here. So it really doesn't change the question if there is 3 people or 5 people. We're not asking how many chairs are there, and I'm not asking if the question was how many chairs did the lift have, then that might have some relevance. But the question is really asking how many people are there in the air at any given time. So it really doesn't matter if it's a double chair or a triple chair. Alright, let's get started with the next question on the Kansas Tech. So this question, the first part of the question was pretty easy. How many times does the Kansas Tech turns its inventory? So Kansas Tech. The first question was really inventory turns. Inventory turns is COGS divided by inventory. In this case, COGS is 110 million and 50,000. Inventory is 20 million. So this comes out to be 5.5 turns. So basically, the company turns the inventory 5.5 times per year. The second question is the tricky one. We can do this in a 2-step. I would normally do it in a slightly different way, but to make it to match it with what we have been doing till now, let me do this in a two different step. The first part of the question says, well, what is the cost? What is the inventory cost per unit? The normal thing to do is, well, we know we have 35% inventory cost per year, and we have the inventory turn of 5.5. That means we flip the inventory. We flip the inventory 5.5 times, but the holding cost of the per unit per year is 35%. That means the per unit inventory cost per is 6.36%. But the question asks you, give me the answer in terms of dollars, right? What is the per unit inventory cost for the radio for in terms of dollars? So now the question is 6.36 of what, right? 6.36. If you just leave this in 6.36, you're pretty close to the answer, I would think. I would probably not deduct any points, and now I just noticed that I never really mentioned give me the answer in terms of dollar. In the exam I would probably say give me the answer in terms of dollars, but this is pretty close to the answer. But the question is 3.36 of what? As we know, in all inventory turns calculation we only use COGS. So obviously we know that this is the 6.36 of the COGS of the radio. But now the question is, what is the COGS of the radio? We know we sell the radio for 50 bucks. Obviously that's not the COGS. If that were the case, we would be losing money. But now we have to find the COGS of the radio. Well, if this is our cost price, suppose you bought something for $100, right? You sold that for $150. That means you have a margin of 50%, right? You have a margin of 50%. Similarly, you bought something for $110,050,000. You sold it for $155 million. What is the margin? Well, the margin really is $110,050,000 multiplied by 1 plus this margin, whatever that is, must be equal to 155 million. If you solve this, the margin will come to be about 41%. Okay, so what that is saying is, whatever the COGS is for the radio now is, the COGS for radio, you multiply this 1 plus 41%, then you should also get 50. Exact same equation, right? Here there was the COGS of the whole thing, here is the revenue for the whole thing, here is the COGS for the radio, here is the revenue for the radio. If you solve this, the COGS of this radio will come out to be $35.5. So that's what the answer really is. It is this 35.5, or the 6.36% of this 35.5. If you calculate this, this is 6.36% of 35.5. You'll get the answer to be $2.26. To calculate this cost, there's a slightly easier way to do it. The concept comes from your knowledge from fraction. That is, whatever this the ratio of 110,050,000 divided by 155 million, the ratio between the COGS of the radio to the price of the sale price of the radio, these two ratios must be same, because this is the COGS of the whole thing, this is the sale price of the whole thing, this is the COGS of the radio, this is the sale price of the radio. The last line in the question says assume the margin is constant. So the COGS of the radio, if you solve this, should also give you $35.5. Earlier we had gotten the inventory cost per unit is 6.36%. So 6.36% of 35.5 is $2.26. So either way, we find that the per unit inventory cost of the radio is $2.26.